This video contains the solutions for your Chapter 6 area packet problems. We'll see how far we get. It may include all problems or maybe just these free response. So first one, we have a graph of f prime. You don't want to be intimidated by this. We're just still finding the area under that, and we're finding area under f prime, so this is f prime, so no big deal there. First thing we want to do here is find the exact area. Well, let's see. This exact area, this is made up all of geometric shapes that we can figure out. So this is a triangle. It's a 1 by 1 triangle, so it's 1/2 base times height. It's above the x-axis. And then we have here, this is negative area minus, that's a 2 by 2 triangle. Sorry, I might have said rectangle there. I meant to say triangle. 2 by 2, base times height. Okay, now this is tricky. You look at this and you see a circle, but remember, this is the area that we're talking about, right? So this area, which is negative, consists of, it's really this rectangle minus the semicircle, right? Picture this whole area of this rectangle shaded in. We want that whole rectangle minus the semicircle, right? As if we did the area of the semicircle, that's not the area between the curve and the x-axis. We want these little pieces in here. So that's the area of a 2 by 4 rectangle minus the area of a radius 2 semicircle. It would be 1/2 pi times the radius squared. So that's the actual area here. Let's see if we can simplify that a little bit. 1/2 minus 2 minus 8 minus 4 minus 2 pi. Let's see, that's be negative 10, that'd be minus 9.5, or let's see, what is that? 9.5 is 19/2, I guess, plus 2 pi, looks like. Okay, there's the exact area. Now we want to use a left-hand Riemann sum of 7 equal subdivisions. Well, it's 1, 2, 3, 4, 5, 6, 7. So those are all 1 wide. So each rectangle has a base of 1 and a height of whatever the y coordinate is for the left endpoint. So that'll be 1 for this one. For this subinterval, the height is the y coordinate, the left endpoint, that's 0. For this one, that would be -1. Remember, area can be negative, that's a negative rectangle. And then for this one, it's 1 wide and -2 is the height. And then this one, this is a tricky one, let's see. That would be, if this were the unit circle, then there would be a point 1/2, comma, square root of 3 over 2, right? But this is the times 2, so you go over 1 halfway there, would bring you up to the square root of 3. So in other words, instead of like 1/2 square root of 3 over 2, all the distances are doubled, so that turns into like 1 comma square root of 3. So if this were the center, this would be 1 over and square root of 3 up. But in fact, it's down 2. So this y coordinate right here, it's 2 minus the square root of 3. You can spend a little bit of time thinking about that. And it's negative, right? So it's -2 minus the square root of 3. That's the tricky one here. We'll have the same thing there. Then, okay, next rectangle has a height of 0. Right, we're back on the y-axis there. And the next one, what do we have? 1, 2, 3, 4, 5, 6. And the last one has the same height as this one. So we just have another one of those. Plus another 1 times minus the square root of 3. Again, that's a little tricky to get that coordinate, but everything else should be straightforward. So let's see what happens here. I've got 1 plus 0 minus 1 minus 2. And we've got 2 of those, so minus 4 plus 2 square roots of 3, and then that's another 0. So it looks like the total area is negative 6 plus 2 on the square root of 3. All right. And then last, we want to find this area from negative 2 to 2. Remember that when we go backwards, that flips the sign. So that's the same as negative. That's the same as that. I don't know about you, but I just like to go ahead and get these in the right order, from left to right, from low to high, and then if it needs to be flipped, bring in a negative sign out there, then so be it. So we want to go from negative 2 to 2. Let's see, from negative 2 to 0 is, let's do this, we'll say, that's the integral from negative 2 to 0 plus 0 to 2. I forget that that has to be in parentheses. I'm being lazy here, right? This is of f prime dx, all that stuff. But that's negative. All right, the area from negative 2 to 0, that's a negative rectangle. It's a 2 by 2, so that'd be 1/2 2 times negative 2. Hold on, did I make that negative twice? Yeah, I did, didn't I? So it's a negative rectangle, so I've just made my negative sign out here. So only one negative sign. It's a negative area. This negative out here is here because, because the integral is backwards. And then I have more area that is also negative. It's a square, a 2 by 2 square, minus a quarter circle, 1/4 pi r squared. All right, let's see if we can clean that up. This is negative 4. This is minus 4 plus pi. So that's negative 8 plus pi. Switch the sign, so it's 8 minus pi. Alrighty. Okay, questions 4 to 6 refer to the graph of f given above. Use your right Riemann sum of 6. Let's see, 1, 2, 3, 4, 5, 6. So it looks good. 6 equal subdivisions to approximate the integral from negative 3 to 15. Notice that each one of these is 3 wide. So right Riemann sum. Each one of them will be 3 wide. This one, if you take the right endpoint, it's a height of negative 1. Oh, no, it doesn't. It has a height of 0. Sorry. Haha, just kidding. It has a height of 0 for its right endpoint. Plus 3 times. This next one has a height of 1. And 3 times. This one has a height of 3. And then a height of 1. And a height of 0. And then a height of negative 1. You notice here that everyone is, they're all the same width, so you could have factored out the 3 and done it like 3 times 0 plus 1 plus, and then just add up all the y coordinates for the right endpoints. So that'd be 4 times 3 is 12. All right, that's our approximate area there. Number 5. Use a midpoint Riemann sum of 3 equal subdivisions. So if there's 3 equal subdivisions, now they're each 6 wide, right? So I'll factor out the 6 this time. Each one is 6 wide, and then the midpoints of those, the height of this one at the midpoint is 0. The height of this interval at the midpoint is 3. And the height of this one at the midpoint is 0. 6 times 3 is 18. Notice that gives us a different, considerably larger estimate there. All right. Use a trapezoidal sum of 6 equal subdivisions to approximate the integral, or the area. So, let's see. Trapezoids, again, they're going to all be 3 wide. And then we do the average of the bases. So, using our trapezoid formula, if they're all the same width, that averaging, the 1/2 on the inside of each one of those, is going to come out to the front, right? And then in here, every height gets used twice, except for the very ends, right? Because everything else gets to play a part in 2 different trapezoids. So, let's see what our heights are. We got -1, and then 2 times all the ones that are on the inside, all those heights. It's 0, 1, 3, 1, 0, and then -1 again. Right? These are all doubled again because each one of these heights, all these y values, like this one for example, plays the role of the right-hand edge or base of this trapezoid, but it's the left-hand base of this trapezoid. So that's why all these get used too, except for the ends, right? They only get to do one side of one trapezoid. So let's see if we can clean that up. Got 5 times 2 is 10, minus 1 minus 1 is 8, times 3 is 24 divided by 2 is 12. Same as that one. All right. Question 7 and 8 refer to the graph of f given above. Left Riemann sum of 6 equal subdivisions. That's 1, 2, 3, 4, 5, 6, so that looks good, to approximate the integral of the f function, right? So that'd be these values here. Well, let's see, how wide are they? It looks like each subinterval is half wide, so those are all the widths of the rectangles, and then the left endpoints would be those, right? So -1, -4, -6, -7, -6, -4. There's my 6 left endpoints. Notice that if you do right endpoints for this one, it ends up being the same because it's symmetric with respect to the y-axis here. But no matter. So let's see, we got -11, 18, 28. Half of that is -14. All right, let's try trapezoids. Now, notice here that we're doing trapezoids with 3 equal subdivisions. And I think I probably meant to make that one f prime because we have those in there, but I didn't, so I never needed that data there. So trapezoids going from, that's like 1, 2, 3 subdivisions, right? From here to here, here to here, right? That's 1, 2, 3. Okay, so how wide is each one? Looks like they're 1 wide. And there's the divided by 2 from the average of the bases. So then let's see, the endpoints get used only once. These ones get used twice, right? And then the endpoint just once again. So let's see, I got negative 12. No, sorry, that's negative 12 times 2. Negative 24, 25, 26. Half of that is negative 13. Well, fairly close, but different approximations. Okay. Question number 9 refers to this table. We want to find an approximation, the area from 0 to 8 under this t of x function using a trapezoidal Riemann sum with 4 subdivisions. Notice it didn't say 4 equal subdivisions because we don't have equal subdivisions here. So when we do trapezoids with unequal subdivisions, we really have to think about like the area of each trapezoid separately. So let's set that up. This trapezoid has a height of 1. I remember we think about them sideways. We think about that as the height. It's got a height of 1 and times the average of the bases. The average of those would be 100 plus 93 over 2. And then the next trapezoid is 4 wide, and the average of the bases would be 93 plus 70 over 2. And the next one is 1 wide again. The average of the bases, 70 plus 62 over 2. And the last one is 2 wide, and average of the bases, 62 plus 55 over 2. All right, so let's see what that gives us. The average of these would be 96.5 times 1, plus that cancels out to a 2, so I have 163 times 2, which is 326, I think. You can check my math calculator there. This is just the average of those two, which is 66, plus those cancel out. 62 plus 55 is 117. All right. And then we add those up. Where is my calculator? Let's see. If this were 100, then that plus this would be 426, but it's 3.5 short. So that's 422.5. 422.5, 482.5, 488.5. Plus this is going to be, let's see, how much would it take to get this up to 111.5? That's got an extra 5.5, so that's 600 and, I don't know, you can check the numbers there, something like that. Sorry, I should have a calculator for that. Okay. Now, let's see if we can figure these out. These are using the properties of integrals. These are actually really easy problems once you get a handle on this. So this says the area from 1 to 9 under this function is -1, and the area from 7 to 9 is 5. We want to find the area from 1 to 9 of negative 2 fx. Well, remember, if there's a constant in here, that can just come out to the front, right? And if these are in the wrong order, then you can switch them. That just pops another negative sign out. So that second negative sign makes that positive. And that's given, right? That's one of the ones that we know. This is just -1, so 2 times -1 is -2. All right, now 1 to 7 or 7 to 1, we don't have that, but isn't it true that the area from 1 to 9, if we subtract the area from 7 to 9, then what's left? Just the area from 1 to 7, right? And think about this geometrically. If you've got the area from 1 to 9, whatever it is, whatever it looks like, and we subtract, right, we've got the area from 1 to 9, and we subtract this, then you're just left with 7 to 9. Oh, did I subtract the wrong piece? Sorry, I meant to say you've got the whole thing and you subtract the 7 to 9, that would leave you, likewise, with 1 to 7, which is what we're interested in, except upside down. So the area from 9 to 1 is -1, minus the area from 7 to 9 is 5. So that would be -6. So the integral from, or the area from 1 to 7, f of x dx, would be -6, which means 7 to 1, if they're upside down, that just flips the sign. F of x dx is equal to +6. Okay, so same considerations here. This just has a 2 here. We'll talk about later on. The variable that's actually in here doesn't make any difference. Whether this is f of x or f of z, these are the numbers that are actually from here to here. So this letter in here doesn't make a difference. Could be anything. So I hope that didn't throw you off. So this is just 2 times that. So 2 times this. The 2 can come to the outside. So that's just 2 times 2, or 4. And then just like we did here, 3 to 4, well, 0 to 4, if you subtract the area from 0 to 3, you're left with the area from 3 to 4, right? So that's 2 minus -3. So this area here is 5, but we want the upside down version of that, so that's -5. Okay, now let's see if we can make any sense of these things here. We're looking at rectangles here. We're adding together 4 rectangles. That's what we want to think of these as, like a sum of some number of rectangles. So we're adding up 4 rectangles, and each one of them is 1/4. The width is 1/4, right? That's going to be the same number every time. And the height is 1/4 squared, 2/4 squared, 3/4 squared, 4/4 squared as we tick through these values, right? So it's 1/4 squared, 2/4 squared, 3/4 squared, and then finally 4/4 or 1 squared. So what function are we looking at? I think we're looking at underneath the squaring function, right? Each one of these things got squared, and if each interval is 1/4, and we eventually got here, I think we're talking about this is a right Riemann sum for the area from 0 to 1 under the x squared function. Right? From 0 to 1, we chopped it into 4 subintervals, so that would be this integral. This one's almost identical. Each one is 1/10 wide, and we're doing the sine of 1/10, 2/10, 3/10, all the way up to 1. So it looks like this is the integral from 0 to 1 of sine x dx with 10 rectangles, right? This one's a little trickier. Looks like we're going not from, we're dividing it up into n rectangles. And so we chopped it up into n subdivisions, and then this is ticking through all the way up to n. But once again, when this gets all the way up to, when k gets all the way up to n, this is just going to be 1 again, cubed. So again, it's just an integral from 0 to 1. This one all the way up to, from k equals 1 to n, right? So when that gets to n, it's just n over n. What's happening to those? They're getting cubed. The only difference here is we've divided This one was 4 rectangles. This was 10 rectangles. And this one is a little bit more general expression. This was n rectangles. But it's an approximation of that integral, or that area. Okay, I'll do the multiple choice in a separate video.